welcome back to Teach Astronomy. Oh, I was double micing it, wasn't I? I'm sorry if that was super loud and possibly echoey, but hopefully the problem has been solved. But hello, everyone. Happy Monday morning or afternoon or evening, wherever you are. Today we are going to be doing some more book reading. So, like it said in the title, we are doing the second half of Chapter 3 of Dreams of Other Worlds, which is kind of technically Chapter 4 of Dreams of Other Worlds. It's confusing. It's the one about Voyager. But we read the first half last week and enjoyed it quite a bit, but it is a super long chapter because there's a lot to cover because Voyager's a really big, Voyager's a couple really big missions. So we are going to be finishing that up today and just having a good time hanging out. Hello, Student McLeod and Lynn Jersey. Welcome to the stream. Hope you guys are doing good this fine Monday morning. Gonna take a drink of water before we start. And I guess we'll just hop into it. So last time I think we stopped right after we were talking about the pale blue dot image. So that was the image that... Oh, I don't even have my photos up. Hold on. I'm so unprepared. Not that unprepared, actually. I had a bunch of time before stream today because I woke up kind of early. But I totally forgot about the pictures. But let me pull that up. So we were at Pale Blue Dot, which, if you guys recall, was the photo that Voyager took after it had passed all of the solar system and gone pretty far out. Yeah, we're in Chapter 3. We're in the middle of Chapter 3. Where's my... There it is. So we had been looking at this. That right there is Earth from very, very, very far away. And yeah, so the next section that we're talking about is Voyager's Golden Record. So if you're following along and you have the soft cover of the book, and this is my edition of the book, so it might be a little different, but we're about on page 91. So hopefully that helps if anyone's following along. All right, so let's not just elbow my whole keyboard and turn the stream off. All right, Voyager's Golden Record. Attached to each Voyager spacecraft is a gold-plated copper phonograph record conveying greetings from Earth to civilizations potentially inhabiting nearby exoplanets in our galaxy. Though not the first spacecraft to carry salutations from Earth, Voyager is the first to send our voices, music, and photographs. Pioneer 10 and 11 carry a plaque that includes a map of nearby pulsars indicating the Sun's location in the Milky Way, a schematic of our solar system, their flight path from the third planet out, and an outline of the Pioneer spacecraft with the outlines of a man and woman standing in the foreground to demonstrate the human's shape and comparable size. The male figure has his right hand raised in a sign of greeting. By contrast, Voyager carries much more detailed salutations to potential species that might happen upon the spacecraft. The idea of attaching greetings from Earth to the Voyager spacecraft apparently was suggested by John Cassani, who served as project manager for Voyager from 1975 to 1977. In October 1974, Cassani had scribbled on a routine JPL concern and action report, quote, "No plan for sending a message to our extrasolar system neighbors," end quote, as well as the phrase, "send a message." Cassani asked Carl Sagan to coordinate putting together a message. Sagan was a natural choice to head the effort. He and Cornell astronomer Frank Drake had organized development of the Pioneer 10 and 11 plaques. Sagan understood the powerful public impact of a greeting to possible galactic civilizations, eagerly accepted Cassini's mandate, and recruited a group of scientists, professors, and business leaders for the NASA Voyager Record Committee. Sagan additionally consulted with science fiction writers Arthur C. Clarke, Robert Heinlein, and Isaac Asimov, and gathered a core group of collaborators, including Drake, who in 1961 developed an equation for calculating the number of civilizations that might populate the Milky Way. Writer Anne Druyan, science writer and Professor Timothy Ferris astronomy-inspired artist John Lumberg, and artist Linda Salzman-Sagan, who drew the images for the Pioneer plaque. This core group selected the messages, sounds, music, photographs, and diagrams now hurtling into the interstellar abyss. Oh, and thank you. Oh, there's a whole website for, I was going to show you guys a picture, but there's an entire website, which is super cool. There we go. So this is the Voyager Sounds of Earth website from JPL. So you can go in here and there's a bunch of information about what's on the record. You can listen to some of the stuff on the record. You can see the pictures. You can see the cover of the record. You can learn about its history and manufacturing. It's very, very cool. They have some of the music listed here. They've got the sounds, which is really cool. And all the greetings. Here they are. So all the greetings audio clips are here to listen to. I wonder if the aliens who get it will convert it to MP3. I wonder. All right. Inscribed in the grooves of the Golden Record is an essay of sounds of Earth. Spoken and written greetings, humpback whale song, 115 photographs and diagrams related to nature, science, and human activities, and 90 minutes of music. Murmurs of Earth, an account of the compilation of the interstellar record, reveals an intense deliberation that went into selecting its contents and determining the medium that would best preserve the special envoy from Earth. It was Drake who recommended using the equivalent of a phonograph record that could record sound as well as photographs that would render as television images. Since corrosion does not occur in the vacuum of space, it was calculated that, excepting a direct collision with micrometeoroids or other space debris in the outer solar system, the records might remain intact for 1 billion years. Quote, "We felt like we were on the committee for Noah's Ark, that we were deciding which pieces of music and which sounds of Earth would be given eternal life. Really 1,000 million years. We took it as a kind of sacred and joyful task," end quote, recalls Druyan, who gathered the audio clips for the record's 12-minute sound essay. The sound essay begins with a musical rendering of Kepler's Harmonica Mundi, a mathematical treatise transposed into sound at Bell Telephone Labs. Quote, "Each frequency represents a planet. The highest pitch represents the motion of Mercury around the Sun as seen from Earth. The lowest frequency represents Jupiter's orbital motion. The particular segment that appears on the record corresponds to very roughly a century of planetary motion," end quote, explains Druyan. Following this are sounds of the primordial Earth, volcanoes, earthquakes, thunder, and mudpots. To illustrate the evolution of life, ocean surf, rain, and wind are followed by crickets and frogs, then vocalizations by birds, hyena, and elephants, and a chimpanzee. Human footsteps, heartbeats, and speech, and laughter come next, and fade into the sound of fire and of flint being struck by rock to indicate the evolution of tool use. These are followed by a tame dog's bark, and the clamor produced by sheep herding, blacksmithing, sawing, and agriculture. Next is Morse code tapping out the phrase ad astra per aspera, which translates as to the stars through difficulties, a suggestion by Carl Sagan. To trace the evolution of travel technologies in the 20th century, the clatter of horse cart and noise of an automobile segue to an F-111, is that how you say it? Segue to an F-111 flyby and the cacophony of a Saturn V liftoff. Concluding the sound essay are juxtaposed sound files of electromagnetic waves of human brain activity, actually those of Druyan, in case an advanced civilization could read human thoughts, and the radio output of a pulsar, a collapsed star in rapid rotation. As Druyan points out, quote, "My recorded life signs sound a little like recorded radio static from the depths of space. The electrical signatures of a human being and a star seemed, in such recordings, not so different, as symbolized our relatedness and indebtedness to the cosmos." Frank Drake and artist John Lomberg were tasked with putting together the Golden Record's photo essay and selecting images that might make sense to a non-human species. Lomberg has sent more of his own art into space than perhaps anyone. Having designed the sundial on the Spirit and Opportunity rovers and created the Visions of Mars DVD attached to NASA's Phoenix lander as a message to future generations who explore the red planet. For Voyager's record, Drake and Lomberg compiled 115 photos and diagrams depicting insects, wildlife, ballet dancers, bushman hunters, various landscapes, architecture, an X-ray image of a hand, a radio telescope, the Earth in space, an astronaut spacewalking on orbit, and even a sunset. Chosen in part to illustrate Earth's beauty and because, quote, the reddening of the light contains information about our atmosphere, end quote. The elegantly etched aluminum cover of Voyager's record indicates how the record is to be played, and is Lomberg's work as well. On the right of the cover are illustrations of the appropriate vertical to horizontal ratio for television images of the photographs and what the first image, a simple circle, should look like. On the left are top-down and side-view graphics showing proper placement of the enclosed stylus and the correct RPM speed in binary. The Golden Record is not a conventional 33 1/3 RPM long-playing record, as is often claimed. Wanting to include as much data as possible, the committee realized they could embed more music and images if they slowed the playtime to 16 2/3 revolutions per minute. Near the bottom right of the record cover is a diagram to indicate that the transition period of a hydrogen atom between its two lowest states, so 0.7 billionths of a second, should be taken as equivalent to 1 in binary code. This is intended to give an accurate speed for spinning the record, and for interpreting the pulsar map at the bottom left that depicts our sun relative to 14 pulsars whose precise periods are This is intended to give an accurate speed for spinning the record and for interpreting the pulsar map at the bottom left that depicts our sun relative to 14 pulsars whose precise periods are notated in binary code. The committee was adamant about sending music as a form of art, particularly since music expresses a potentially universal mathematical language. But with only a 90-minute segment dedicated to music, agonizing decisions had to be made in representing musical genres of the world. Hurtling into the depths of space are selections, among others, of Havanese Gamelan, an initiation song from Zaire, Japanese Shakuchai, I think that's how you, Shakuhachi, a raga from India, Melanesian panpipes and drum from Peru, a Bulgarian shepherdess song, a Navajo night chant, tribal music from New Guinea, Louis Armstrong performing jazz, Chuck Berry playing rock and roll, and classical selections by Mozart, Bach, Stravinsky, and Beethoven. Also included is the Cavatina movement of Beethoven's String Quartet No. 13 in B flat, Opus 130, along with an image of sheet music from the selection. It was a piece that Beethoven so cherished he once told a colleague he could cry when thinking of it. In researching Beethoven's Cavatina, Druyan found on the score of an ancient opus that the composer had written, quote, "What will they think of my music on Uranus? How will they know me?" End quote. Beethoven apparently, comments Druyan, quote, "toyed with the thought that his music might leave our planet," end quote. His intuitive query seems indicative of an artist who saw far beyond his time. For that, and for his deafness, he was often misunderstood or considered eccentric. While reworking the finale rejected by his publisher for the String Quartet No. 13, Beethoven apparently strolled through fields waving his arms, shouting, and likely singing, certainly in an attempt to feel, since he could not hear, the music playing in his mind, and that he found so compelling. So, it seems a perfectly harmonious outcome that Beethoven's music indeed traveled to Uranus, and at this moment, aboard Voyager, is barreling into the pristine interstellar void. That's the end of that section. Or if aliens think of humans. I hope aliens don't think we're tasty. I would love for that not to be the outcome of all of this. Gotta send more Chuck Berry. You know they want it. What would you... Actually, that's a good question. If you guys were part of this committee, I guess a new committee. It'd be a new committee because this was... I want to allow things that have come out since Voyager's been launched. What if you could pick one song, any song, what would you send? Maybe as a representation of the last, like, when did Voyager leave? The 80s, I think it was. We discussed this. No, in the 90s. I can look this up. It's, give me the mission status, please. They launched in the 70s. That's right. Okay, 77. So there has been several decades since they've launched. So anything after like mid 70s. If you could add anything, add like one song, what would it be? Let me know. I will continue reading while you decide. All right. Greetings from Earth. Linda Salzman Sagan coordinated the recording of Greetings from the People of Earth. In an attempt to reflect the diversity of our species, the committee deliberately recruited volunteers from as many cultures, languages, and dialects as possible. The team decided to record greetings in the most commonly used languages, as well as salutations in languages so ancient they are no longer spoken, such as Akkadian, Sumerian, and Hittite. To avoid complete anthropocentrism, the committee also included humpback whale song to give a voice, as Carl Sagan noted, to, quote, another intelligent species from the planet Earth sending greetings to the stars, end quote. Actually, humpback whale song are a shared form of communication and are now understood as cultural artifacts transmitted over hundreds or thousands of miles between humpback communities. Whale researcher Ellen Garland reports that specific songs are passed between humpback whale groups from west to east across the Pacific Ocean. The humpbacks learn the songs from each other and teach them to other whales, indicating, quote, cultural change on a vast scale, asserts Garland, who, along with her colleagues, documented the same song, consisting of newly learned phrases transmitted from one population to another. The researchers in the 1970s were only beginning to recognize whale song as purposeful communication. When Druyan inquired about a recording of humpback whales for the interstellar record, zoologist Roger Payne responded, quote, proper respect. Oh, at last. The most beautiful whale greeting was once heard off the coast of Bermuda in 1970. Please send that one. End quote. Druyan comments, quote, when we heard the tape, we were enchanted by its graceful exuberance, a series of expanding exultations so free and communicative. We listened to it many times, and always with a feeling of irony that our imagined extraterrestrials of 1 billion years hence might grasp a message from fellow Earthlings that had been incomprehensible to us. End quote. Both fascinating and revealing are the 55 human salutations on the Voyager record. As might be expected, several people sent wishes of peace. Many simply said hello. Carl Sagan's son, Nick, who was then about 6 years old, offered, hello from the children of planet Earth. End quote. Health and wellness marked a key refrain among the messages. A significant number of volunteers either wished presumed inhabitants of exoplanets good health or expressed concern regarding their wellness. For instance, Stella Fessler, speaking in Cantonese, sent this greeting. Hi, how are you? Wish you peace, health, and happiness. In Russian, Maria Rubinova said, be healthy, I greet you. Saul Mubola in Nyanja, a language of Zambia, asked, how are all you people of other planets? Mang Miao Lwin in Burmese queried, are you well? Liang Ku commented in Mandarin Chinese, hope everyone's well. We are thinking about you all. Frederick Ahul stated in Welsh, good health to you now and forever. In Zulu, Fred Dube sent this message, we greet you, great ones. We wish you longevity. Andrew Selesky in Ukrainian stated, we are sending greetings from our world, wishing you happiness, good health, and many years. In Korean, Soon Hee Shin wondered, how are you? And Margaret Suk Ching and Si Gubar in the Amoy language of Eastern China, asked, "Friends of space, how are you all? Have you eaten yet? Come visit us if you have time." Slightly more than a quarter of the greetings explicitly mentioned wellness, good health, or longevity. These salutations in particular seem to reflect a primal preoccupation with physical well-being. This is not surprising. For now, humans struggle with ubiquitous illnesses, such as the common cold or influenza. Oh, that hits close to home right now, huh? Severe and persistent back pain, a pervasive problem for upright walkers, or recovery following traumatic injury. The many wishes of good health to possible galactic neighbors on the Voyager record suggest awareness of our own ephemerality. That's the end of that section. Somebody said Chuck Berry playing Johnny Be Good. Oh, is that the song that's on the record? Let me check. I think it is. Yeah. That's awesome. That's very cool. Yeah, if you guys want to, I probably shouldn't play that as kids of copyright issues, but if you guys want to listen to the song that they sent from Chuck Berry, Student McLeod put that link in the chat. Somebody said "Hallback Girl" by Gwen Stefani. It's a good one. Oh, Rocket Man is so good. I love that song. It's a great movie too. They made the movie about him. Is very, very good. Great song. All right. Let's keep on going. Okay. Let me move my chair. Okay. Message in a bottle. 30 years after their launch and billions of miles from Earth, the Voyager spacecraft continue to transmit data on their way into interstellar space. NASA will track Voyager and listen for its transmissions until the spacecraft falls silent, so that we might learn something about what writer Stephen J. Pine calls the, quote, soft geography of the outer solar system and what lies beyond. Their secondary mission, to carry messages of greeting beyond our sun, may, to some, seem futile. Pine and others have noted that very low likelihood that even if another species came across the spacecraft, they could figure out how to play the phonograph record or even recognize it as a message. Today's teens, if presented with a copy of Voyager's record, might find the task difficult, if not impossible. Okay, excuse me. I'm not a teen, but I know how records work. Chris, I was a teen when he wrote this book. I have a record player. But okay, all right, fine, I'll give you that. Quote, by the time Voyager reaches Jupiter and Saturn, writes Prin, vinyl phonograph records were overtaken by magnetic tapes. By the time it reached Uranus and Neptune, tapes were fast fading before CDs. By the time it reached the Helios sheath, CDs were passé compared with digital drives and iPods. The phonograph was hopelessly archaic, just as the golden record reached the edge of the solar system. In technology years, barely beyond cuneiform tablets. End quote. As Pine sees it, the Voyager spacecraft are in many ways ill-equipped for their journey into the unknown. Quote, they were leaving the solar system with computer power inadequate to run a cell phone, and electrical power insufficient to animate a clock radio. Yet they had much yet to survey. The dynamics of the solar wind, reversals in the sun's magnetic field, interstellar particles, radio emissions from various sources within and beyond the heliosphere, and of course the interstellar medium, if all went well. End quote. However, in spite of Voyager's technological limits, Pine describes the spacecraft as the stuff of legend, whose tales will be told in future ages. Quote, for now, it continued to send back reports from new settings. It was doing what no other spacecraft could. Its narrative simply defied the closure from the Earth. End quote. Voyager's ability to communicate with Earth is certainly limited by its plutonium supply. But like the species that launched it, the spacecraft and its record demonstrate their resilience precisely when faced with seemingly insurmountable limitations. Timothy Ferris, who coordinated the music selections, speculates that even if Voyager's record is someday retrieved but proves indecipherable, it nevertheless conveys a clear message. Quote, "However primitive we seem, however crude the spacecraft, we knew enough to envision ourselves citizens of the cosmos. We too once lived in this house of stars, and we thought of you." End quote. Despite the possibility of becoming extinct, and precisely because we might, we sling these auspicious spacecraft into the unfathomable depths out of an innate optimism that runs deep in our species. The odds against another civilization retrieving and playing Voyager's record are astronomical, and yet we sent them in the recognition that understanding the universe and our place in it has mattered deeply from our earliest beginnings. Voyager's interstellar mission inadvertently and silently speaks of two intrinsic human traits. We are relatively physically fragile and, like other species, prone to extinction. And yet we possess an inexplicable capacity to hope even in the most dire circumstances. This instinctual, undaunted ability to hope against all odds must have evolved early on in Homo sapiens as a survival mechanism. So far, it has worked. We are the only extant hominid. And such unyielding expectation, despite seemingly insurmountable circumstances, has produced some of humankind's greatest accomplishments. It was that kind of resilience that compelled Beethoven, though completely deaf and fatally ill, to nevertheless compose some of his most acclaimed works. During Apollo 13, when it seemed the mission and possibly the crew were lost, NASA's engineers and astronauts refused to give up and brought the crew home via gravity assist. It was with similar abandon and hope that we sent Voyager's greetings to possible other galactic civilizations. Sagan eloquently illustrates this point. Quote, "Billions of years from now, our sun, then a distended red giant star, will have reduced Earth to a charred cinder. But the Voyager record will still be largely intact, in some other remote region of the Milky Way galaxy, preserving a murmur of an ancient civilization that once flourished, perhaps before moving on to greater deeds and other worlds on the distant planet Earth." End quote. Fly Me to the Moon is a good one. Somebody said Barry Manilow tunes will keep them away. I don't know if I know any Barry Manilow I'm sure I've heard them, but I can't think of like a song by Barry Manilow. We're gonna look it up. What does he make? What are his popular songs? He's 77. Give me a song list. Give me a top song. Google Mandy. Weekend in New England. It's a Miracle. Copacabana. Mandy, yeah. Charlie said Mandy. I don't know if I've listened to like any Barry I know I haven't listened to any Barry Manilow intentionally, I have to say. Fly Me to the Moon's a good one though. Frank Sinatra. I feel like Frank Sinatra, Elton John, maybe some, oh my gosh, what's his name? Throw on some Bruce Springsteen there, get that New Jersey representation maybe. Oh my gosh, I'm trying to think of who does Piano Man? Billy Joel. I feel like they're all very like, as far as Americana kind of stuff goes, that'd be a good representation of very, very classic Americana music. Sweet Caroline, and then they'll sing along, yeah. Bum, bum, bum. The Boss, yeah. What about that one song? I feel like Sweet Caroline and that other I think it's just called West Virginia, have the same energy. They both got that, like, you can't not sing along to one very specific part and you have to scream it. So maybe we'll send that song, Almost Heaven, West Virginia. Get Together by the Youngbloods. Peace and love vibes to the aliens. I don't know if I've I've listened to the Youngbloods. I don't know if I've heard that song, Get Together. Or unless it's the, like, is it the Get Together? Yeah, yeah, yeah. Let's see. No, I think this is a different song. It sounds nice, though. I'm looking at the lyrics. Who sued a radio station? Bruce Springsteen? Or the guy who wrote the West Virginia song? I did not hear about this. All right, I'm gonna keep reading, but let me know who sued a radio station. That sounds wild. Okay. Envoy to the galaxy and to ourselves. All human cultures communicate by signaling greetings, which serve as an opening that usually indicates a lack of hostility. Whether a presidential address, evening news program, a letter, telephone message, or a friend or stranger's passing acknowledgement on the street, we anticipate salutations. Greetings also are an opening to what the ancient Greeks called xenia, hospitality to the unknown other. Biocultural theorist Brian Boyd contends that among ancient Greek cultures, the extension of hospitality, or xenia, initiated collaboration among strangers in a hostile time and region. Particularly in the Iliad and Odyssey texts, hospitality, asserts Boyd, is a core value. Quote, the word xenos, stranger guest host friend, tells a The word xenos, stranger guest host friend, tells a whole exemplary tale in a single word. When a stranger arrives at my doorstep, I am obligated to welcome and feed him, even before asking him who he is. The stranger becomes my guest, and to signify that he has therefore also become my friend, I should bestow on him a valuable gift at his departure, and help him on his onward journey. He is then obliged, should I arrive on his threshold, to become my host. But more than that, the bond of xenia created by the initial act of welcome and cemented by the gift should endure between us for life and between our descendants. End quote. As an example of this, Boyd mentions a scene from the Iliad in which a Greek and a Trojan warrior refused to fight as their relatives were xenoi. From its inception, Voyager's record was understood to be as much a message to ourselves as it was to those who may encounter it. Included are greetings from President Jimmy Carter, who wrote, quote, this is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so that we may live into yours. We hope someday, having solved the problems we face, to join a community of galactic civilizations. End quote. Even as Voyager extends hospitality to possible galactic civilizations, Carl Sagan often reiterated that we must extend to neighboring nations, those we know quite well, and equal largesse if we wish to survive millions of years hence. That was the point of Sagan's talk given in 1988 on the 125th commemoration of the Battle of Gettysburg. Quote, today, there is an urgent, practical necessity to work together on arms control, on the world economy, on the global environment. It is clear that the nations of the world now can only rise and fall together. The real triumph of Gettysburg was not, I think, in 1863, but in 1913, when the surviving veterans, the remnants of the adversary forces, the blue and the gray, met in celebration and solemn memorial. It had been the war that set brother against brother, and when the time came to remember, on the 50th anniversary of the battle, the survivors fell, sobbing, into one another's arms. They could not help themselves. End quote. Though seemingly ill-equipped for their mission, Voyager carries from a tiny blue dot of a planet into the unfathomable abyss a gift, a small repository of human artifacts, music, and greetings, offering not just xenia, but charity that neither expects nor requires reciprocity. That was the attribute that ensured our survival as a species, and likewise has informed our dream of becoming members of an advanced galactic community. Quote, in their exploratory intent, wrote Sagan, in the lofty ambition of their objectives, in the utter lack of intent to do harm, and in the brilliance of their design and performance. These robots speak eloquently for us. That's the end of that section. Ooga shaka, more cavemanish. Aliens can relate. I can't help this feeling. Barry Manilow sued for insulting his songs. That's the wildest thing I've ever heard. For what? Defamation or something? That's crazy. Oh my god. That's funny. Man, yeah. There's so many interesting song selections on here. It's very cool. There's a Peruvian wedding song. There's a song from a Chinese artist called Flowing Streams. Dark Was the Night, written and performed by Blind Willie Johnson. It's cool. Cool stuff. Imagine being one of the people who got to perform for this record. Like, just imagine. I mean, like, you know, first of all, it's like the people who like made the songs, right? But then, you know, who got to perform the, you know, the Bach, you know, fugue in C, or, you know, Beethoven's String Quartet number 13. Well, it's listed who did it. It was played by the Budapest String Quartet. But imagine being part of the Budapest String Quartet and your conductor comes in one day and goes, okay, so NASA just called and they want us to record a song for them so they can shoot it into space. That'd be cool. I used to play the violin, so I was part of an orchestra. And let me tell you, if my conductor had said that, I would have practiced a lot more. All right. Gustav Holst, The Planets. Jupiter and Mars especially. Gustav Holst. Oh, Gustav, yeah, I've heard of him. He's an English composer. Yeah, he lived between like the end of the 1800s to the 1900s. But yeah, he has the full suite of planets. That would be really cool. Yeah. That would be a good choice. Those are nice. I've listened to a couple of them. They're very pretty. All right. Emissaries of Peaceful Exploration. Voyager's interstellar mission summons up the voiceover at the beginning of what began as a seemingly minor television series, initially aired between 1966 and 1969, titled Star Trek. Quote, to boldly go where no man has gone before. End quote. Those words, immortalized by William Shatner in his role as Captain James T. Kirk of the Starship Enterprise, have powerfully shaped popular discourse regarding space exploration. By the late 1960s, Americans were tuning their televisions to watch the space drama created by Gene Roddenberry and developed along with Herb Solow, Gene Kuhn, Matt Jeffries, and Bob Justman. The impact of Star Trek had been unprecedented and unparalleled. In decades of syndication, the series would inspire and captivate a global audience. Film historian Constance Penley points out that in the cultural discourse, Star Trek became inextricably linked with NASA. Describing the conflation of NASA and the television series in its various iterations as a, quote, powerful cultural icon, Penley contends that, quote, NASA and Trek shapes our popular and institutional imaginings about space exploration, end quote. By 1976, NASA and Star Trek were so intertwined in the popular thinking that, at the request of Star Trek fans, President Gerald Ford was persuaded to change the name of the newly unveiled prototype space shuttle from Constitution to Enterprise. Penley writes, quote, many of the show's cast members were there at the Enterprise, as the Enterprise was rolled out onto the tarmac at the Edwards Air Force Base to the stirring sounds of Alexander Courage's theme from Star Trek. End quote. Then JPL director Bruce Murray recalls that a year later, in 1977, when the Voyager spacecraft was launched, funding for the planned Jupiter Orbiter with Probe, JOP, project had been canceled. That summer, Gene Roddenberry happened to be speaking at a Star Trek convention in Philadelphia and encouraged the 5,000 attendees to contact their congressional representatives to save the mission. Whatever the reason was for the reversal, the Jupiter mission eventually was supported, as was the Galileo. Oh my gosh. As was the Galileo orbiter. That Star Trek touched a powerful chord in the public sphere. That Star Trek touched a powerful chord in the public sphere is unquestioned. William Shatner has observed that the original Star Trek series went on to become the most successful television series ever produced, and has evolved into a huge industry comprising spun-off TV series, motion pictures including J.J. Abrams' Star Trek in 2009 and Star Trek Into Darkness in 2013, as well as novels, cartoons, action figures, Trek conventions, and many marketing products. By aligning the space agency with the Star Trek franchise, NASA has realized even greater public interest. In 2011, the Kennedy Space Center attracted visitors with the Summer of Sci-Fi, where science fiction meets science fact. The event was designed to combine the technology, innovation, and exploration of NASA with the adventures of Star Trek. Its website featured a retro image of Spock, modeled on the 1960s series, with his hand raised in the Vulcan greeting of live long and prosper. Activities included a live theater production that posed the audience as new recruits for Starfleet Command, a shuttlecraft simulator, Star Trek The Exhibition, and an opportunity to win a suborbital flight with X-Corps Aerospace, whose Lynx aircraft is to be piloted by former astronaut Rick Searfoss. The Voyager mission was even featured as a plot device in Star Trek The Motion Picture, 1979, when Kirk reunites with his former crew to save the Earth from a sentient spacecraft that eradicates everything in its path as it searches for its creator. I have watched this movie. If you have watched this movie, please let me know, because we should talk about it, because it's crazy. The leaf blowers have returned. Speaking of Captain James Tiberius Kirk, yes. There's at least 6 Voyagers launched. Yes! Yes. Yeah. In this movie, if you haven't seen it, watch it. It's a cinematic masterpiece, and I only say that half sarcastically. We watched it for a special effects class, and I honestly loved it. It's very much more 2001 than 2001: A Space Odyssey than it is Star Trek. But William Shatner's still there doing his thing. Leonard Nimoy's crushing it as Spock. You have your favorite characters there. It's a good time. They wear really weird clothes, though. It's very strange. But this is a picture of, as Student McLeod mentioned, this is Voyager 6, actually. Because they did launch Voyagers 3, 4, 5, and 6. They didn't. That's just a Star Trek thing. But they very much embrace the Voyager missions as part of plot devices in the Star Trek series. So that was cool. So, unfortunately for Kirk and his crew, the entity views them as a carbon-based infestation of starships. It gains sentience after unknown aliens repair the old Earth spacecraft that forms its core, the name of which is V'ger, a corruption of the word Voyager, and likely derived from the acronyms given the Voyager spacecraft. A test model of Voyager was labeled VGR-77-1, while the spacecraft actually launched were titled VGR-77-2 and VGR-77-3. On a recent NPR Science Friday program, Ira Flatow asked Ed Stone about his reaction to the film, to which Stone replied, quote, "I thought it was a really wonderful idea to take the spacecraft and somehow make it part of a sentient being. Of course, that's science fiction, but it really does illustrate the impact Voyagers had on the public imagination." End quote.
The popular conflation of NASA and Star Trek produced a deep cultural narrative about the possibilities of exploring the universe through international and peaceful collaboration. Roddenberry's altruistic vision of human civilization 400 years in the future is evidenced in the name chosen for his fictional starship. In deliberate counterpoint to the first nuclear-powered aircraft carrier, the USS Enterprise, Roddenberry christened his vessel the United Starship Enterprise, and assigned its crew a mission for the peaceful exploration of space. Currently, Richard Branson's Virgin Spaceship Enterprise, or VSS Enterprise, is poised to be among the first to offer commercial space tourism flights, and is so named in recognition of Star Trek. There's a lesson to be gleaned from the history of a low-budget television series, which was canceled after its third season, that nevertheless has produced such an enduring vision for humankind's peaceful future. John Wagner and Jan Lundin assert, quote, "Myths are a people's deep stories, the narratives that structure their worldview," end quote. They point out that Star Trek and its spin-off series frequently drew upon ancient myths to rework them into a modern mythos about equality, regardless of ethnicity or species, and of a future time when humankind organized into a federation of planets. When humankind organized into a, quote, federation of planets has eliminated intolerance, exploitation, greed, war, and materialism, end quote. Penley likewise claims that, quote, an astonishingly complex popular discourse about civic, social, moral, and political issues is filtered through the idiom and ideas of Star Trek. And this, in part, explains why the series has been such a hugely popular story of things to come, end quote. In Pale Blue Dot, Sagan wrote, quote, "The visions we offer our children shape the future. It matters what those visions are," end quote. Cultural narratives, even those spun from fiction, can powerfully shape a generation and a culture's vision for survival in ages long hence. Among the deeply resonant narratives of space exploration informing our generation is Voyager's epic journey, and Sagan's apt commentary on the spacecraft's view of Earth from the edge of our solar system. "Look again at that dot," he admonished. Quote, "That's here. That's our home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment the earth is where we make our stand. To me, it underscores our responsibility to deal more kindly with one another, and to preserve and cherish the pale blue dot, the only home we've ever known," end quote. That's the end of the section. Good morning, Bill Nash. Morning, nerds. You're not wrong. Hello, Single Coded. How you doing? We've almost hit the hour. I told you guys this chapter is crazy long. I was like, oh, we might get through the whole thing in an hour. We still have like 1, 2, 3, 4, 5, 6, like 7 full pages or so. It's long. And this is the second half of the chapter that we're doing today. And it's already taken like an hour to get through the first half of the second half. The third quarter, one might say. All right. You loved it. I'm glad. We're gonna keep going. Yeah, I like how much detail Chris went into about the the stuff that was put on the golden records and like why it matters, and like its cultural significance, both like for us sending it out into space, but also for us here on Earth. I think that's cool. All right. Getting to the worlds next door. To get a sense of the gulf of space that lies between us and the nearest star systems, let's return to the scale model from the start of the chapter. Visualize the Earth as a golf ball, a little less than half a mile from a glowing 20-foot diameter globe that represents the sun. Light speed shrinks at distance, as distance does in the model, slowing to just under 3 miles per hour, a steady walking pace. The moon is a few feet away, a light travel time of just over a second. Mars is 1,100 feet away, a 15-minute stroll. The outer gas giant Neptune is 12 miles away, which is 4 hours of light travel, or walking in our space model. We have shrunk space by a factor of 230 million. Think of it as a map with a scale of 1 to, 230. Yeah, a scale of 1 to 230 million. Instead of writing it as million, he just put all the zeros, and I was like, that's a big number. At the moment, Voyager 1 is 48 miles away, and Voyager 2 is 37 from Earth. And let's see if that's actually accurate, because I want to give you the current. At the moment... Oh, this isn't our model. I was like, it's not that close. I can't do the math right now. But right now, Voyager 1 is 14 billion miles away, and Voyager 2 is 11 billion. So that reduces to somewhere around about 50 miles away for Voyager 1 and like 40 miles for Voyager 2, because this book is a few years old. Proxima Centauri, the nearest star system, is 2,000 times farther away, just over 100,000 miles in this scale model. In the real universe, if it's taken the Voyagers 35 years to get where they are today, it would take them around 70,000 years to get as far as the nearest star. This daunting isolation makes other worlds seem out of reach. The trajectories of the Voyagers were never intended to aim at a particular star. They will each drift past other stars as the eons pass. In approximately 40,000 years, Voyager 1 will come within 1.5 light years, or 9 trillion miles, of an anonymous star in the constellation Camelopardalis. Meanwhile, Voyager 2 is heading towards Sirius, the brightest star in the sky, and will pass within 25 trillion miles of it in 300,000 years. Long before then, in less than 25 years, both spacecraft will lose power for all of their instruments and become silent sentinels gliding through the Milky Way. The stars seem as far away as ever. With the Space Shuttle program over and the International Space Station expensive and unpopular among most scientists, who don't see it as a cost-effective or compelling platform for research, NASA is struggling to recapture the vision that fueled the Apollo program and the golden age of planetary exploration epitomized by the Voyager probes. Reaching the stars will take much greater speeds that are currently possible. Traveling at the highway speed of 55 miles per hour, Proxima Centauri is a 50 million year trip. At the speed of the Apollo spacecraft, it's a million-year trip. And Voyager traveling at 37,000 miles per hour would take 80,000 years to get there. Sending a probe to a nearby star in a human lifetime runs into the obdurate principle of physics. Reaching a speed 1,000 times faster than Voyager requires 1,000,000 times the energy, since kinetic energy is proportional to velocity squared. The space program so far has been powered exclusively by chemical rockets, which are inefficient because they get their energy from chemical bonds. Fusion releases energy from atomic nuclei and is 10 million times more efficient. Sending a shuttle-sized craft to Proxima Centauri in 50 years would take about 10 to the 20 joules, which is the amount of energy consumed in the United States in a year. Unfortunately, that would require 500,000 kilograms of hydrogen fuel, and fusion technology is nowhere near being able to put that capability into a shuttle-sized package. Ideally, there would be no need to carry and accelerate all that fuel, but solar sails don't work efficiently when far from a star, and there's not enough interstellar hydrogen to scoop up and use along the way. It sounds like a bridge too far. And I have a figure to show you guys. Let's see. Excuse me, picture. Let me show my viewers the picture. Okay. So this is a little map of where everything is. So it says the Voyager and Pioneer spacecraft have traveled beyond the orbits of the outermost planets and are now in the uncharted territory of the heliopause. So that's that weird orbit is Pluto, and then all the others are contained in there. And you can see that both the Pioneers and the Voyagers have left the solar system and are in this outward part of the solar wind, heading toward the termination shock. I don't know if they've actually passed the termination shock now, but at least when this book was written, they hadn't. And it says the solar wind meets the diffuse medium between stars at the termination shock, which is a hot and nearly perfect vacuum. At their speed of travel, it will take tens of millennia for the Voyagers to reach the nearest stars. So we have the termination shock here, the heliopause, and then the bow shock. I actually do not know what the differences between these are. I just know that the termination shock is where the solar wind kind of ends, I believe. And then, yeah, the closest stars aren't even on this map because they're so far away. But yeah. Student McLeod's comment is very nice. It is it's a long chapter, but there's a reason for it because Voyager was very important. Yeah. Very important time, very important missions. All right. At the speed of light, traversing the span of our galaxy would take 100,000 years. Even so, we dream of plying the eternal wastes beyond that. It is a remarkable aspiration for such a fragile species. Some engineers consider interstellar travel an impossible goal. That may be, but in launching spacecraft in the direction of Earth's rotation, we use in a very simple way a natural energy resource of our planet. Similarly, Voyager harnessed the rotational energy of the large outer planets to sling itself from one planet to the next. In essence, though the gravity assist deployed in Voyager and other missions, through the gravity assist deployed in Voyager and other missions, we tap into a resource of the solar system itself, and, however minutely, borrow energy from it, and leave our mark on the rotation of nearby planets. Sagan, who characterized walking and driving on the moon or using gravity assist as natural steps in human evolution, wrote of Voyager, quote, "They are the ships that first explored what may be homelands of our remote descendants. Unless we destroy ourselves first, we will be inventing new technologies as strange to us as Voyager might be to our hunter-gatherer ancestors." End quote. Research on propulsion concepts for interstellar travel was undertaken at NASA's Glenn Research Center from 1985 to 1992, and then the seed funding of $1.5 million ran out. One tangible result was a 740-page volume that quickly became the Bible of propulsion science. Project leader Mark Millis offered a cautionary note to NASA's Breakthrough Propulsion Physics website. Quote, "On a topic that this visionary and whose implications are profound, there is a risk of encountering premature conclusions in the literature, driven by overzealous enthusiasts as well as pedantic pessimists. The most productive path is to seek out and build upon publications that focus on the critical make-break issues and lingering unknowns, both from the innovators' perspective and their skeptical challengers. Avoid works with broad sweeping and unsubstantiated claims, either supportive or dismissive." End quote. Yet the visionaries are alive and well. Sorry, there was a weird cadence and it threw me off. Yet the visionaries are alive and well, and planning for a future when we will slip the bonds of the solar system. In a move that mirrors the U.S. government's encouragement of the private sector to develop new launch capabilities, in 2011, the Defense Advanced Research Projects Agency, DARPA, initiated an annual strategic planning workshop and symposium to bring together a wide range of technologists, engineers, members of space agencies, entrepreneurs, space advocates, science fiction writers, those working in medicine, education, and the arts, as well as the general public. Organized to foster collaboration among these groups, as well as academicians and financiers, The 100-Year Starship project isn't immediately planning to design a starship that could travel to the stars, but is hoping to kickstart private-public partnerships that will address the technical problems of interstellar travel in the next 100 years. Colloquia for the project focus on propulsion at light speed, medicine and space travel, possible destinations, the economic, legal, and philosophical implications, as well as the need to communicate a vision for interstellar travel through narrative or storytelling. The 100-Year Starship Initiative exemplifies the potential of an idea, suggested in mere fiction, to become reality. Flip cell phones modeled on the Star Trek communicator, desktop computers, downloadable MP3 files, iPods, and iPads were all inspired by the fiction of Star Trek. Chief Engineer and Mission Manager for NASA's Dawn spacecraft, Mark D. Raymond, attributes his design of ion propulsion for interplanetary spacecraft to a Star Trek episode titled Spock's Brain, in which the term was used. The ion propulsion powering the Dawn mission allows continuous firing of its engine, so the spacecraft can attain speeds surpassing chemical propulsion. Similarly, the Qualcomm Tricorder X Prize competition, which was launched in 2012 by the X Prize Foundation for the first team to develop an inexpensive device to readily diagnose illness, is yet another Trek-inspired potential innovation. And I have a figure for you. Well, it's just a photo, I guess. But it's fun. So here is a picture of Gene Roddenberry's Starship Enterprise. So this is specifically a replica of the Enterprise on display at the Famous Players Colossus Theatre in Langley, British Columbia. And the rest of the caption just says that, it's Star Trek has very clearly been a huge influence on how people see NASA and space and understand it all and get excited about it. So yeah. All right. Futurist Ray Kurzweil thinks we are facing a critical stage in human evolution due to exponential advances in information technologies, genetics, nanotechnology, and robotics. Kurzweil and others anticipate that emerging technologies in three-dimensional printing will radically change the world, as we know it. Myriad items can be produced via 3D printers, including parts for flyable aircraft printed out of plastics, or complete components for buildings that could be printed from liquid concrete. Made in Space, a fledgling company inspired by Singularity University, based at the NASA Ames Research Center in California, and co-founded by Kurzweil and Peter Diamandis, has proposed using 3D printers on the International Space Station or for establishing outposts on the Moon or Mars. In 2011, NASA funded research focused on printable spacecraft, as well as 3D printing technologies to construct planetary surface habitats. When astronauts return to the Moon or someday walk on the surface of Mars, they may carry 3D printers with them and computer files for printing the tools and habitat components needed to build livable space habs using nothing more than lunar regolith or the ruddy dirt of Mars. The process of 3D printing involves a sequential layering of powdered or liquid plastics or metals, even potentially human cells. The medical community is interested in using human stem cells to print three-dimensional vertebral discs for repairing spine injury, or a human heart or liver as organ transplants. In the next 30 years, Kurzweil predicts disease will be eradicated through this and other medical advances in biochemistry, gene therapy, and bio and nanotechnologies. He may be on target given the success of researchers at MIT who are in the developmental stage of a drug that can destroy human cells infected with viruses while leaving normal cells untouched. So far, trials with mice eradicated H1N1, the most common flu virus in humans, and the drug looks very promising in effectively treating stomach viruses and the common cold. Kurzweil anticipates that in the next few decades we will begin to incorporate artificial intelligence the size of a blood cell into the human body to enhance our health as well as our intellectual and computational capacities, so that it will be possible to extend our lives for hundreds or thousands of years, possibly even indefinitely. That is not an unprecedented idea. Consider Turritopsis dortni. The immortal jellyfish discovered in 1988 by marine biology student Christian Sommer and now being researched by marine biologist Shin Kubota. Upon reaching maturity, the jellyfish reverts in age to its nascent state and then begins life again. The organism's natural life cycle doesn't ever end. Kubota believes that in unlocking the jellyfish's genome, humans too might become immortal. In such a scenario, human missions to nearby stars seem nearly feasible. If we're not attached to sending humans, with our present need for expansive life support, nanotech might propel us into interstellar space even sooner. Exoplanet hunters like Geoff Marcy and Deborah Fisher are studying the two brightest stars in the nearby Alpha Centauri system, the nearest solar systems to Earth and comprised of 3 suns. In October 2012, a graduate student at Geneva Observatory, Javier Dumusk, detected a planet comparable in mass to Earth orbiting the star Alpha Centauri b. Though this exoplanet orbits too close to its star to be habitable, the general consensus among astronomers is that where there is one planet, there are likely to be more. Fisher, though not associated with the discovery, has called the finding, quote, the story of the decade, end quote. Progress in the detection of exoplanets has been stunning. Starting with the first detection of a Jupiter-mass object in 1995, Earth-mass exoplanets are now routinely detected both with ground-based and orbiting telescopes. Unfortunately, studying these planets in detail from afar will be extremely difficult. Think of a golf ball seen at a distance of 100,000 miles. Listen to what Marcy hopes will happen next. Quote, NASA will immediately convene a committee of its most thoughtful space propulsion experts, and they'll attempt to ascertain whether they can get a probe there, something scarcely more than a digital camera, as let's say 1/10 the speed of light. They'll plan the first ever mission to the stars. End quote. If there is an Earth next door, Alpha Centauri will become the compelling destination that the moon was 50 years ago. Assuming the tricky issue of miniaturized propulsion can be resolved, nanobot probes can be small enough that the energy requirements are tractable. They'll take pictures of the habitable worlds and we'll see them back on Earth within a generation. These pint-sized emissaries will be able to carry far more information than the quaint phonograph records of the Voyagers. Their digital storage will contain the sum of all human knowledge. With the Voyagers, we took our first tentative baby steps beyond the solar system. The future beckons. And that's the end of the chapter. That was fun. I hope you guys enjoyed learning about Voyager. Lots of big ideas towards the end of that chapter. Very exciting. Throat's getting scratchy. That was a lot of reading, a lot of tongue tying. But yeah, also a quick Zephram Cochrane will achieve warp drive April 5th, 2063. For Evan to watch Star Trek First Contact. Yes. Hey, I mean, it's very possible. But before I leave you guys, I wanted to give you the Voyager website again. Just if you want to learn more about Voyager, JPL has an entire website right there. It is great. It has all the information on where they are now. You can do a little, there's like a little, I don't know if you call it a simulation, but you can see where the spacecraft is in real time and like look at it, look back at the solar system. Obviously not with Voyager, but in a little simulation thing. There's mission timelines. There's information about the Golden Record with all those audio and picture files. Lots of cool stuff. So if you guys want to, there's also a very cool poster. Oh, you know me. I love the NASA travel posters. Look at this. Look at this. Okay, I don't want the text, but these are really cool. These are so cool. Since 77. Voyager. The hits just keep on coming. That's really, really cool. I love these. The Grand Tour. Oh, these are so fun. I love when they do stuff like that. And there's some other pretty cool pictures too, but like, oh, so fun. But yeah, so you guys should check out the website. Like I said, there's the status of the missions and their science instruments and stuff like that. All the stuff in the golden record, cool pictures, stuff like that. It's a very cool website. So check it out if you want more Voyager info. You want to know if I can match the salute in the it's the live long and prosper, right? Yeah, I know how to do it. Is the thumb out? I never know. I guess the thumb is out. Yeah, of course, of course. Come on. Yeah, there's Leonard Nimoy as Spock. Yeah, Leonard Nimoy was great. Rest in peace. All right, well, I guess that's about it for today. As far as the rest of the week goes, we will have a stream on Wednesday, unless LA decides to turn my power off again, because there's another substation fire, because that's what happened last week. But I mean, I'm hoping it doesn't happen again. It'd be crazy if it did. But we'll have a news stream on Wednesday. And then immediately after the news stream, Professor Impey will be doing his Q&A right here. So you can just kind of roll into the next one. It'll be a good time. And then Friday we have amateur astronomy. And I think that's pretty much it. Oh, and if you guys weren't here on Friday, mark your calendars for... what's his name? Does somebody know the first Russian in space? Let's see. Yuri. Oh, it does? That's weird. Oh, if you looked at it earlier, I thought I updated it, but maybe it didn't save, but I'll check that in a second. Yes, Yuri Gagarin. I may have just butchered his last name, but Gagarin. There we go. But it is Yuri's Day on the 12th, Monday, April 12th. And or Yuri's Night. They call it Yuri's Night. It's a celebration every year to to celebrate the milestone of sending a guy into space. It's very exciting. And normally there's a lot of like celebrations and stuff around the world, and Professor Impey said he's gone to a lot of them, and I have not personally gotten to, but it sounds really cool. I'm upset that no one told me that this was a thing that astronomers did, but okay. But since we can't really go anywhere or celebrate in person this year, we thought it would be really fun to do something on stream. So we're not sure if it's going to be either here or on the YouTube channel, but on Monday, April 12th, Professor Impey wants to do a special lecture all about Yuri's flight and some other things about, human space flight and things like that. So it's going to be really cool. It's going to be a lot more scripted than our normal thing here. So he's going to... Sorry, I'm getting a spam phone call. But he's gonna talk a bunch about... he's gonna present a cool lecture, and afterwards we'll probably have some sort of Q&A. We can all hang out. It'll probably not be a normal time. It might be a little later than normal. We're still trying to figure out the details, but just want to let you know that's gonna happen, and it's gonna be really fun. So yeah, I think that's pretty much it. Thank you guys all for joining me today and hanging out, and I will see you for the next one. Bye. My mouse is on the wrong screen. Okay, bye.